For decades, the story of human evolution seemed clear. Our own genus, Homo, was the innovator, the trailblazer who first picked up a stone and shaped it into a tool. This invention, we believed, set us on the path to becoming human. But what if that story is wrong? What if another ancient relative, a distant cousin who walked a different evolutionary path, also possessed the spark of technological ingenuity? Today, we're exploring a paradigm shift in paleoanthropology, a scientific controversy that forces us to reconsider the very definition of humanity. We're putting our own ancestors on trial and asking, were we the first tool makers? Or did that title belong to our enigmatic cousin, Paranthropus? To understand this debate, we first need to meet the hominin at its center. The name Paranthropus means beside man, a fitting label for a genus that lived in Africa for nearly 1.5 million years, coexisting with our early ancestors before vanishing from the fossil record. There are 3 known species: Paranthropus ethiopicus, Paranthropus boisei in East Africa, and Paranthropus robustus in Southern Africa. Collectively, they're known as the robust Australopithecines, and for good reason. Their most striking features are their massive dish-shaped faces, huge cheekbones, and enormous molar teeth, some up to 4 times the size of our own. A prominent ridge of bone, a sagittal crest, ran along the top of their skulls, anchoring the powerful chewing muscles needed to process what was assumed to be a highly specialized diet of tough, fibrous foods like roots, nuts, and seeds. For a long time, the prevailing wisdom was that Paranthropus was an evolutionary dead end, a quote, chewing machine that specialized its body for food processing, while our genus, Homo, specialized its brain and hands, relying on technology. This simple narrative began to crack in 1959, when Mary Leakey discovered a P. boisei skull at Olduvai Gorge alongside early stone tools. Initially, she proposed this hominin, which she called Zinjanthropus, was the toolmaker. But this idea was quickly overshadowed by the discovery of Homo habilis, or handyman, at the same site. With a larger brain and more human-like features, Homo habilis became the prime suspect, and Paranthropus was relegated to the sidelines of the tool use debate for decades. But now, this robust cousin is making a dramatic comeback. The first question in determining if an ancient hominin could make tools is a matter of anatomy. Did they have the right stuff? For years, this was a major roadblock for Paranthropus, as the fossil record consisted almost entirely of skulls and teeth. But a landmark discovery changed everything. Researchers found the first hand and foot bones unambiguously associated with a Paranthropus boisei individual dating back 1.5 million years near Kenya's Lake Turkana. The analysis of these hand bones revealed a stunning mix of features. The thumb-to-finger proportions were remarkably similar to modern humans, indicating a capacity for a precision grip, the ability to delicately pinch objects between the thumb and fingertips. This grip is absolutely essential for the fine motor control needed to make and use stone tools. At the same time, the wrist and palm were more robust, similar to a gorilla's, suggesting a powerful grip useful for stripping bark or perhaps providing the force needed for striking stones. The finger bones were straight, not curved like tree-climbing apes, which, along with foot bones indicating an upright gait, confirmed Paranthropus was a ground dweller. The researchers concluded that there is, and I quote, nothing in the hand anatomy that would prevent Paranthropus from making and using tools. While their grip might not have been as refined as later humans, they likely had the necessary dexterity for the job. This anatomical evidence is a crucial piece of the puzzle. It shows Paranthropus was not just a chewing machine, but a creature with a versatile anatomy. The potential for tool use was physically present. But potential is one thing. Proof is another. The most compelling case for a tool-wielding Paranthropus comes from the archaeological record itself. At a site named Nyayanga, on the shores of Lake Victoria in Kenya, researchers unearthed a treasure trove of stone tools dating to an astonishing 2.9 million years ago. These tools, part of the Oldowan toolkit, represent one of the oldest known examples of this technology. What makes Nyayanga so revolutionary is the discovery of two Paranthropus molar teeth in the same geological layer as the tools and the butchered bones of hippos. This direct association provides strong circumstantial evidence that Paranthropus was, at the very least, present where tools were being made and used to process large animals. The Oldowan toolkit was simple but effective. It involved striking a stone core with a hammerstone to detach sharp-edged flakes. These flakes opened up a new world of food, allowing early hominins to cut through animal hides and access nutrient-rich meat and bone marrow. The Nyayanga discovery not only pushes back the date for this technology by hundreds of thousands of years, but raises the explosive possibility that Paranthropus, not Homo, might have been its inventor. And Nyayanga isn't an isolated case. At Swartkrans, a cave site in South Africa, a large number of bone tools have been found alongside Paranthropus robustus fossils. Microscopic analysis shows these tools were likely used for a specific task: digging into termite mounds to access a rich source of protein. Crucially, Paranthropus remains are far more common than Homo remains at this site, making it the more likely candidate for being the tool user. So let's build the case for the prosecution. Why should we believe Paranthropus was a toolmaker? First, the direct association of their fossils with tools at multiple sites like Nyayanga and Swartkrans. The repeated co-occurrence is becoming difficult to dismiss as coincidence. Second, the anatomical capability. The P-Boise hand bones prove they had the necessary dexterity and grip for making and using simple stone tools, dismantling the old argument that they were physically incapable. Third, the dietary benefits. Tools would have been a game changer. Hammerstones could crack hard nuts, and sharp flakes could access meat and marrow, as the hippo bones at Nyayanga suggest. This points to a more versatile and opportunistic feeder than previously imagined. Fourth, we must confront our own historical bias. The man-the-toolmaker idea has dominated paleoanthropology, leading researchers to automatically attribute tools to Homo whenever their fossils were found nearby. The new evidence forces us to question this assumption. Finally, consider their success. Paranthropus thrived for about 1.5 million years. The ability to use tools could have been a key factor in their long-term survival, helping them adapt to changing environments. However, a healthy dose of skepticism remains. Let's hear the case for the defense. The most common counter-argument is the Homo habilis factor. Early members of our own genus were present in the same places at the same times. The argument is that Homo habilis was the true toolmaker, and Paranthropus just happened to die in the same locations, leaving a coincidental association of bones and tools. Another possibility is a predator-prey relationship. Perhaps Homo habilis was using these tools to hunt and butcher Paranthropus. In this scenario, the tools are not the work of the deceased, but the leftovers from their demise. Then there are the limits of anatomical evidence. While the hand bones are suggestive, capability doesn't prove action. It's possible Paranthropus used its dexterity for other complex foraging tasks and never crossed the threshold into stone tool production. And finally, there's the sheer weight of scientific tradition. The man-the-toolmaker paradigm is a cornerstone of human origin studies. Overturning such a long-held idea requires an extraordinary amount of evidence, and some argue we're not there yet. The possibility that Paranthropus was a toolmaker has profound implications. It would shatter the traditional, linear model of our past, where a single line of hominins marched inevitably towards technological mastery. Instead, it suggests that the capacity for technology was not unique to our genus, Homo. It may have evolved independently in multiple hominin lineages, painting a much more complex, bushy picture of our family tree, with different branches experimenting with different evolutionary strategies. This discovery also forces us to rethink what it means to be human. If tool use wasn't our exclusive domain, then the line separating us from the rest of the natural world becomes blurrier. It also challenges the narrative of our own superiority. The genus Homo survived while Paranthropus went extinct, a fact often attributed to our technological prowess. But if Paranthropus also had tools, the reasons for their extinction become far more complex. Perhaps it was diet, social structure, or simply bad luck in the face of climate change. The question of whether Paranthropus used tools remains one of the most exciting debates in science today. The case is stronger than ever, built on a convergence of anatomical and archaeological evidence. But the burden of proof is high, and alternative explanations must be fully explored. What is clear is that Paranthropus can no longer be dismissed as a simple chewing machine. This was a complex and successful genus, with a sophisticated anatomy and the potential for complex behaviors. This entire debate is a powerful reminder of how science works. It's a process of discovery, of questioning old assumptions, and of constantly refining our understanding. The final verdict on Paranthropus, the toolmaker, is not yet in, but the investigation is far from over. As new fossils are unearthed and new analytical techniques are developed, we can be sure that our ancient cousins have more secrets to reveal. The story of our past is a chapter that is still being written,